We'll get started now. Hello, everyone, and welcome. I'm Tom Hunt with Etherdyne Technologies, and thanks for taking the time to join us. We're here today to talk about wireless power, not as a concept and not as a future promise, but as something that's now being designed into real products and real environments. For decades now, power delivery has been built around physical connections, cables, contacts, batteries, connectors. They've worked well, but they also define the limits of how systems scale. As devices multiply, move, become embedded into environments, power becomes the constraint that shapes everything else. What's changed now is that wireless power has matured from a laboratory curiosity into a controllable, engineered infrastructure. We now have the ability to deliver predictable power with known fields, known boundaries, and most importantly, known compliance paths in ways that simply weren't possible even a few years ago. This matters because uptime matters, maintenance matters, and in many applications, from sensors to retail to medical and industrial systems, eliminating physical power interfaces can fundamentally change reliability, service models, and lifestyle costs. Today's discussion is about how wireless power is being deployed in the real world, what problems it actually solves, how systems are designed to operate safely and within regulatory limits, and what it takes to move from prototype to production. We've assembled a panel of people who are working through these challenges every day. This won't be theoretical, it'll be practical, grounded, and candid. With that, let me take a moment to introduce our panel. First, we have the two founders of ETI, Jeff Yan, the CEO, and Robert Moffatt, the chief scientist. These two have been in the wireless power industry for over a decade. They've accumulated over 60 patents and understand what it takes to deliver solutions. Next, we wanted to provide some industry perspective, and so we have invited Dinesh Kithany from Wired and Wireless Technology, an industry analyst from the UK, to share his perspective on the state of wireless power industry. And then finally, something unique to any of these events is we invited a customer. We'll hear from Jon McEwen, VP of Sales and Creative at Pacific Northern, a company focused on delivering solutions in the retail and visual merchandising space. He'll provide insights into what it's like to deploy wireless globally and problems it solves for his customers. So let's get started. Robert, I can't tell you how many times I hear it, but people tell me all the time, well, Nikola Tesla did this back in the 1800s. What's new?
All right. Yeah, thank you. So, yeah, that's something I hear a lot too. So, actually, Nikola Tesla is the person who inspired me to get into wireless power because I was reading about him and his experiments and his vision for a global wireless transmission system, which was, really it's still an inspiring vision even today. It's something that I think inspires a lot of people to work on wireless power. And yeah, he did achieve a lot of great wireless power capabilities more than 100 years ago now. But the technology was still rather limited at his time. It was pre-semiconductor. He had the tools to demonstrate the principle, but was still lacking some of the other technological developments to make it practical in people's everyday life. And I think that was still the case for most of the 20th century. So it's only relatively recently, I think, that wireless power has become actually commercially practical because of a confluence of multiple different factors. I think one of them is the transition from incandescent lights to LED lighting, which dropped the power requirements for light by about a factor of 10 or more. And so it's much easier to transfer that power wirelessly when the power requirements are much lower. And also electronic devices, so Moore's law, shrinking the transistor size means computation takes much less power. So you can actually do practical things in a much smaller size and with less power. And I think also the semiconductor developments. So even in the past 20 years, like if you went 20 years ago, all the MOSFETs that we're using right now in our wireless power systems didn't exist. The MOSFETs available at that time were much slower, much less efficient, had much more resistance. So the wireless power systems were much less efficient and would burn much more heat to generate the same amount of power transfer. So, so all these technological developments have made Nikola Tesla's discoveries commercially practical in terms of the power that could be provided, the efficiency, the cost of the systems, and also the demand. Those factors made it something that's practical now when it wasn't even just 10 or 20 years ago.
Dinesh, from an industry standpoint, why does wireless power matter now? What problem is it actually solving at scale?
Cool, good question. Hi, everyone. Dinesh Kithany here. I think our lives have advanced, industries have advanced, consumer needs have advanced, and technology also advanced. And at the same time, wireless power, what it has been, 100 years back on a different environment, thanks to Nikola Tesla, has now taken roots. In fact, what we have now is a much more advanced version of technology, more developed version of technology, and technology which is ready to be adopted is already being adopted and go into much future there. And most of the technologies, like even until the communications are all wireless now. So why not power? And with some good engineering, good advancements of the technology, I guess we are at the right timing to get this adoption from just not only the mobile phones, but into wider landscapes, into more industries, technology, and applications there.
Thank you, Dinesh. That was great perspective. Jeff, as the CEO of a wireless power company, same question.
Every day, what you experience is hundreds, if not thousands, of wire or battery devices that require electricity. And it's really hard to maintain the state of the system if you want to scale it out even more. And then the only way actually to provide for massive adoption will be, this, I would say one-to-many, more of an infrastructure wireless power transfer.
We've been optimizing our system for a different goal, which is the ease and flexibility of use of the system, which puts us into different markets from the cell phone market per se, and to markets where maximum flexibility is needed. And so our system is designed to provide power over some volume of space, which can be from a size of a desk up to a room, and to allow devices to freely move within that space and receive power wirelessly. And the range of power we've focused on is from about 1/10 of a watt up to 50 watts or so. So that's actually a range that includes the majority of all the electronic devices that people are typically using today and also developing. And so there are other companies working in the space of wireless power, but it's a very broad space. And most of the problems that they're tackling are very different from the one that we're focused on. So there are companies working on charging electric vehicles, for example, but that's a very different problem. And their designs end up looking completely different from ours because of the different constraints of that problem they're trying to solve, and also the different power levels and things like that. So there aren't very many other companies within the same domain that we are exploring this space of maximum flexibility within a predefined volume.
I think the ETI team has been very humble with regards to talking about their technology. And when I talk about the advancement of technology, I think you guys are doing some great job. Again, I'm not saying because I'm on the webinar with you guys, but I think the wireless power industry has been advancing very gradually from a device to device charging, the one-to-one charging. But what you guys are doing is actually very interesting, where you're looking into, see, if you do one-to-one charging, you're not solving a bigger picture or having a cordless environment. You will still have one receiver, one transmitter. There is cable somewhere, but maybe not on the device, but somewhere else. Your solution is very, very interesting because you're doing one-to-many. And that is where I think we are solving a bigger picture out there. We are solving a bigger problem, a more sustainable problem out there, more greener planet outlook out there as well. Because example, and Jeff very briefly talked about the desktop applications, where currently we have wireless charging solutions, where we have a wireless charging solution separately for mobile phone. We have a separate wireless charger for the watch. We have separate wireless charger for, let's say a ring, a smart ring, and many other devices. Say 10 devices on your desktop are all wirelessly charged, but they all are having independently wirelessly charged. What you guys are doing, or technology of your structure is doing, is taking one transmitter, example, which is your desktop, and you're charging all of them with wirelessly. So that is what I think is the future of wireless power. It's not like one to one, but one to many, or even in many cases, many to one as well, in an industrial environment where sensors and all are charged with different transmitters across the environment out there.
Dinesh, thank you. That was great. Um, I might quote you on that. I wondered if you could put your analyst hat on and share where is the state of the wireless power industry? Hype, early adoption, or real commercialization?
Thank you. Good question. Yes, I've been covering wireless power for nearly 10 years in like a deep dive analysis into that market. But before that, also watching it very closely. I would say since then, the market has really evolved. Technology very evolved. While we so far in this call, we discussed about induction-based solutions or resonance-based solutions. But I would say there are ample of different technologies currently available in the market. Some at the development stage, some have already been developed and deployed. Some are ready to be developed and commercialized. There are low-frequency induction-based solutions. There are high-frequency induction-based solutions like 6.78, like ETI is working on. There's also like an NFC wireless charging, and then more interesting, there is also what you call as a distance charging, a very far distance from a meters to kilometers, as far as that. And each of these technologies are looking into different applications. It's not that one application or one technology are combined together for all.
Thank you, Dinesh. Moving over to you, Jon. Everyone today associates wireless power with phones because it's the most readily available thing that they see. Your use case is quite different. Why don't you talk about wireless power in the retail and visual merchandising space?
I would love to, Tom. Hi, everyone. Jon McEwen with Pacific Northern. So a little bit of background about what our company does. We are a highly specialized custom manufacturer of visual merchandising tools, millwork, and displays for the retail world. And we work with a breadth of companies from TJ Maxx to Louis Vuitton and Tiffany. And a lot of these solutions out there that are far beyond just the phones are actually customer interaction points within retail stores. So when you're thinking about window displays and window animations that you're walking by and looking at, a lot of those pieces and items in there are either operated by batteries or, a couple dozen plugs going back and forth in the system. So we've developed platforms and other things for the retailers to be able to take items that we've incorporated with the receivers and eliminate those cable problems and those location problems. So now we can effectively take lit jewelry vitrines or watch vitrines and place them anywhere on some of the millwork surfaces where we've integrated the technology. We can take lighting and different movement applications for some of these pieces within the retail world. And it's really starting to change people's mindset on how they can utilize these pieces and not have to design with cables in mind.
Thanks, Jon. And can I just ask you to address one other issue, and that is, why not just plug these things in?
So that becomes the infrastructure problem within the store design itself. You may have one plug near where a fixture is, and by fixture I mean like a vitrine or a table or a nesting table. And if they want to add several pieces to that, then you start to get multiple wires, multiple needs for multiple outlets. And this really helps to eliminate that when we put this infrastructure into the millwork already and into the fixture.
Thank you for that, Jon. Thanks for the answer, and thanks for being here. Jeff, let me bring it back to you. Same question. Let's talk about non-phone applications. What are you seeing out there? What's happening out there that you can describe at a high level?
So, for example, I will talk about biomedical devices. If you want to have some medical devices that's implant or on body that for example, in a hospital, you don't want to have a lot of wires on your body. It is actually interesting if you can actually provide this a zone of a wire-free power or wireless power that actually all the devices can simultaneously being activated without batteries. But one of the other examples will be, the building management system. So if you want to managing the whole building, that people usually put a temperature sensor, put a moisture sensor for the water leakage, for energy conservation. You need to do a lot of different devices throughout the building. A lot of time they put at least thousands, if not tens of thousands of devices in just one single building. It is very hard to manage and maintain it. And I think the idea that a battery-free and a wire-free device that just spread out in the environment that can be almost perpetually, lived as long as you provide enough power, then actually it's was more than just convenient. It becomes increasing the efficiency and the productivity of the whole system. So our company, we actually identify about 9 different vertical markets, but there are new industry of a consumer product that's coming, not coming, it's sort of on a strong trend scaling out right now, which is more of a PC gaming or the AR and the VR or wearable. So you notice all the wearable that measure your biometrics and AR, VR, which is actually influence your mind, how you interact with the real world. All of these devices require a lot of management on the batteries. So I think this application with a one single unit of infrastructure that can enable multiple devices simultaneously become a must-have, I would say. I think a lot of things we love is almost the magical idea of a wireless power. So we actually talk with amusement parks, the theme parks. We talk with interactive creative toy companies. So there are a lot of highly flexible but also highly creative market that require this removing the constraint of the battery and the wire, become a very desirable market for what wireless power can do.
Thank you, Jeff.
Yeah.
Thanks for going through that. So, Robert, back to you here on this one. And if, Jeff, you want to weigh in as well, please do. I get this question all the time. I know that Jon gets this question all the time, and Dinesh hears about it all the time. So, is wireless power safe? And how does ETI design safety into the system from the beginning?
Yeah, thank you. That's a good question. So, that's something I've been thinking about for actually, I guess, would it be like 19 years now? Because I first started working on wireless power when I was a undergraduate at MIT. I joined a group led by my academic advisor, who's had some fellow professors and a couple of students who were studying wireless power. And we were talking about safety back then, but what's the safe way to do it? And we were exploring some ideas based on Tesla's original approach of using resonance to transfer power between a source and a device that were tuned to the same resonant frequency. Most of Tesla's plans involved using electric fields. So that's why he designed the Tesla coil, which you may have seen. A lot of people use those. Hobbyists build them. They use them in movies for special effects. Actually, that's how I first got into wireless power. I built my own Tesla coil. And so the Tesla coil is designed to generate a huge voltage, and that huge voltage is built up using resonance, and then it can couple to a tuned coil that receives that power. So the problem, though, is the electric field interacts strongly with the human body, because the human body is electrically conductive. So an electric field can cause charges to flow in the human body, and that can cause power to be dissipated in the body, and to generate heat. So when we were first designing our power transmission systems back in 2007, we decided to use magnetic fields instead of electric fields, because magnetic fields at low frequencies just pass right through the body. The body doesn't really have much of a magnetic permeability that differs from air. So the magnetic fields, the human body is almost transparent. And so that also does depend on the frequency, though, because you may have learned a changing magnetic field can create an electric field. And so as long as you have some magnetic field that's not static, like Earth's field is, there will always be some electric component. And that depends on how quickly the magnetic field changes. So higher frequencies will have a higher electric component. And so so things like cell phones, they'll operate in the hundreds of megahertz to gigahertz. Wi-Fi is 2.45 gigahertz. And also there's other like 5G, so that includes some even higher frequency bands, tens of gigahertz. Those have very fast changing fields, so they'll have both the magnetic and electric components. So those always interact rather strongly with the human body and can be absorbed. So that's why a microwave oven can heat food, for example. It's the electric field that interacts with the food that does that. So we use a frequency at our company, 6.78 megahertz. And when I was doing research back in 2007, we used similar frequencies, about 10 megahertz. Those are over 100 times lower than a lot of the communications frequencies that are used. And that means that the electric component can be much smaller. So they interact much more weakly with the human body than microwaves do at those frequencies. And you can actually see that when using our systems, you can put your hand or your body in between the source and the receiver, and the power just flows right through you as if you're not there, because the magnetic field is, your body is almost completely transparent to that field and doesn't absorb that power. That would not be the case with a microwave system. If you stand in the way of a microwave beam, you'll actually absorb it, just similar to a beam of light. So that's one of the ways that we make our system safe. The other way is that we have a transmitter that's designed to always create the same strength of magnetic field, regardless of what's happening in the environment or the loading. So that means that as long as we maintain the field to be at a threshold where it's low enough, it's not going to cause heating in the body, then there's no change in the environment or anything that can cause it to deviate from that and to increase in field strength, which actually is a difficult problem. Most systems that generate RF radio frequency fields, they will be sensitive to the environment and tuning. So if you bring a piece of metal next to them, you can cause it to deviate from the design values, and suddenly you could have a much stronger field than you designed. So that was a big part of our IP that we developed, which is making our system very stable so that no matter what you do in the environment, it always maintains that same field strength, and we can guarantee that's below a threshold that causes any sort of dangerous heating. So we're typically, many times lower than that threshold. So in a typical use case, your exposure, coming from our system is going to be, less than what you would get from any sort of a microwave frequency system like a cell phone.
So Robert, thanks for that. That's reassuring. Are there any regulatory bodies that look into this and certify these solutions?
Yes. So there's the FCC in the United States, which regulates this. So they have certain limits of the amount of heat that can be absorbed, and this applies to all radio frequency systems, whether they're magnetic resonance systems like ours or cell phones. And so they regulate what's called the specific absorption rate, which is how much heat is absorbed in the human body from the fields. And so the average over the whole body for limit for the FCC is 0.08 watts per kilogram for the full body average for the general public, so which they call uncontrolled exposure, which is what we designed to. So there is a higher limit for people who work with radio waves, like radio technicians at a broadcast station or things like that, and they can be exposed to higher levels. But we design our systems to be to meet the limit for the general public uncontrolled exposure limits set by the FCC, and so we're for the typical user quite a bit below that limit.
Jon, I'm going to hit you again. How does product design change when power is no longer delivered through a wire or a battery?
In our world, it changes quite a bit, as you can imagine, because we have to think not just on one piece of a product. Lots of times there's multiple pieces within our product that go together and work together. So like you never think of looking at something that's on display in a retail environment and be like, wow, the power distribution is gorgeous today in that piece. Like what you want to see is just clearly defined product in its hero moment, that's making the consumer want to buy it. And to do that, we've been limited on what we can do with power in certain aspects of retail because we end up with dead screens, we end up with exposed wiring, cords in places, props with batteries underneath them, or batteries no longer working. And batteries just aren't good for the environment either. And that's a big piece that's changing some of that design language. So eliminating the cords and thinking about what the freedom that we have within just that confined space now really leaves a lot of imagination for our VM teams to be able to really design some cool animations and stories, and not just, to your point, product, because our product is so vast and what we offer, from a display stand to a watch stand that now is a smart watch stand that can be wirelessly charged instead of having cables and everything through the display. So it can dramatically change how we design a lot of our products for our customers, and what we even show them when they're rendering ideas and coming up with concepts.
Thank you, Jon. Jeff, over to you. Same question. How does product design change when power is no longer delivered through a wire or a battery?
Yeah, I think that is actually why Robert and I we started thinking about the company. It is removing that aspect of a constraint. It is more creativity that will actually spark. So you could actually think about new design. So people can spend more time thinking about new designs that never existed before, or new artistic way to express at that space and the time and the moment. So what we created is actually trying to remove the constraint of the designer who actually design electronics. So they should be able to design electronics like an artist, like a painting actually. And we target every market with that in mind, because I think internally in our engineering team is also doing the same thing. Is actually you do this almost subconsciously. You don't, once you have this ecosystem as an infrastructure, you kind of thinking the way you design things differently. And we actually, well, this has become interesting, our own kind of a testimonial of how to experience the value of this technology is that we actually first-hand experience ourselves. So the product or the company we work with, they are all actually in a very creative space. So so hopefully that addressed your question, Tom.
Yes, absolutely.
One thing I want to add to the design,
yes, Jon, sure,
too, is the clutter that is created by cords, and then the maintenance that's behind it too. So that drives a lot of that thought in the design process as well. You start to clean up a lot of that, and you start to take away some operational issues too that can happen in environments with a lot of that clutter and cord management. So that helps in our design language.
Thank you, Jon. Robert, I have a question from the audience. They asked, hey, can you talk about the safety for other objects or electronic devices within the field?
Oh, yeah, that's a great question. So, yeah, actually what Dinesh mentioned earlier, I think is a good, it's a good point, because people who, we mainly get asked this by people who have experience with other versions of wireless power transfer systems. So like Dinesh mentioned, electric vehicle chargers. So, so we attend this annual conference, the Wireless Power Technology Conference and Expo, that's been held for many years now, I think over 10 years. And one of the things I see very often at that conference is talk about how to make EV chargers safe, because EVs need tens of kilowatts of power. And one of the problems, which years ago I remember seeing talks about this, is if you were to just drop like a quarter or something on the pavement above the generator coil, it would actually heat it up with magnetic fields enough that the quarter would melt. So it's a huge amount of power that's being transferred, and not only do you have to think about human body safety, but the effect it has on nearby materials. So for the systems that we do at ETI, our power levels are about 1,000 times lower than that. So that helps, first of all, so that prevent things from melting. But the other thing is actually secondly, the frequency that we use. It's like I mentioned, it's tens to hundreds of times lower than the microwave frequencies that are typically used for communication, and that's what makes it interact much less with the human body. But it's also because it's 6.78 megahertz. It's also tens to hundreds of times higher than the other forms of wireless power that are quite common. So like the power that's used for charging cell phones, that's 125 kilohertz. The EV chargers, those operate at 85 kilohertz. So those are about 100 times or so lower frequency than what we use. And those lower frequencies actually have more loss in metals. So they actually, if anyone has an induction cooker on your stovetop, that's actually how induction cookers work. They have a magnetic field that makes currents flow in your cookware, and the resistance of that material just causes them to heat up from Ohm's law. And that happens mainly at the lower frequencies. At higher frequencies, those effects are reduced, actually, because you can transfer the same power level with a much weaker magnetic field because it oscillates faster. And so the magnetic field is much weaker for the same power level, and so the eddy currents are lower, and so these heating effects are much lower. So that also helps our system interact much less with nearby materials, because by using this frequency in the megahertz range, we're low enough that we're not interacting with the human body, but we're high enough frequency we can use a very weak field, and we don't interact so much with metal. And the field strength is it's extremely weak. It's actually weaker than Earth's magnetic field in terms of magnitude. So that means that it doesn't demagnetize your credit cards, because if the Earth's field doesn't do that, neither will our fields. It doesn't interfere much with any sort of electronic devices because the fields are so weak. We did notice in some of our prototypes there was some interference effect with trackpads, so like a laptop trackpad or cell phone. So that's something that we've addressed using advanced filtering. But that is not the damage to the device, but just interference with the function of those devices, because those also use similar frequencies in their detection of your touch sensitivity. So there is just occasional cases of interference that we encounter that we have to address with filtering and things like that. But in terms of damage to other devices, our frequencies are very well suited to avoid any problems like that. But thanks for asking the question.
And Robert, just one other piece there. Talk about what happens in our system when something too big or too metallic shows up in the environment.
Yeah, so I mentioned earlier, we designed our system to be stable against environmental changes. So those could include things like pieces of metal in the environment, because the metal through Lenz's law will tend to oppose a changing magnetic field. So that means that a big sheet of metal, like a metal tabletop or some metal supports in a wall, those will tend to oppose our magnetic field through their induced currents that will have it'll have a canceling field that points the other way, and that our system can work in the vicinity of that because we have a circuit that detects that and adjusts the tuning to cancel the detuning effects that we get, because we operate at resonance. So tuning everything to resonance is extremely important to optimize the efficiency, which is the idea that goes all the way back to Nikola Tesla. But our auto tuning system has a certain limit. to how far it can correct for these sorts of environmental perturbations. And so if the environmental perturbation exceeds that limit, then we have a detection circuit that will detect that it's tuned too far out of range, and will enter what we call a hiccup mode, where the device will just shut down for about a second, and then the transmitter will try to reactivate and sense if the environment has changed, and if not, it'll deactivate again for another second until the perturbing environmental effect is removed. So that way our system can protect the electronics, so protects the MOSFETs from being damaged, from being operated out of tune, and makes the system very robust. We didn't have that in our early system, and we in our early laboratory prototypes, we burned up so many MOSFETs. We have piles and piles of dead MOSFETs that because they don't like being run out of tune. But Tom likes to call our new RF generator bulletproof, and it's been it's been deployed in a lot of environments, and I think we really have solved a lot of those problems.
One thing Robert was mentioning I want to add about safety is that since we are able to keep a stable oscillating magnetic field, which is independent of any application that comes into the environment, that actually also is actually also a creativity aspect, because usually the higher the power you want to do wirelessly, the higher the magnetic field or higher the RF you need to increase to achieve that. But our system obviously still have a limit, but our system, within the limit, we keep the magnetic field constant, which means people who design product doesn't need to think about that. They just think about what they want to design, and when they enter our zone, or our table, then it will just work, and then safely too. So if you think about the beauty of the system like that, we call it one-to-many. So this is another thing that is differentiating us from most of other application or other technique of doing wireless power, is that we are able to use one system as an infrastructure, like a table, and then we can design aftermath, meaning you don't need to design before knowing that. You can design any product that just onto that desk. So this one-to-many aspect is actually very powerful. And we identified this desk application for like a home office or just office desk, is that there are multiple devices that I would say there's a highly dense environment where multiple electronics need to coexist. And we choose that as our consumer approach first, because that is actually the most compelling application for exhibiting our technology. So, Tom.
Thank you, Jeff. Question for everybody. I'll start with Jon. And that is, looking ahead 3 to 5 years, what does success look like for wireless power in your environment?
Great question, because it's when we introduce this to people out there in the market and explain it to them, it's their eyes light up, and they have a sense of like, oh wow, this is magic. You are showing us some magic right now. And looking ahead to that, as people start to understand it, the safety of it all, and get more comfortable with it, in my mind, we're going to see environments that are easier to run, easier to evolve, and just be more compelling for the customer and consumer in general in retail. Having the ease of switching things out, simply cord-free, pulling it out of a box, making it work. I think you'll see a world where things can change just rapidly more in the commercial and retail environments.
Thank you, Jon. Dinesh, how about you?
Quite good. Yeah, what I would like to say is that I'm seeing, wireless power has been developed for so many years, but because there is a misconnect between what it can actually do and what it has been proposed to do, I think that's why it has failed or got rejected to be adopted. Because there were many big promises made, a lot of applications done, wireless power solutions been done. And I think I'll give you one example, a scenario where the way I would summarize that there were many wireless power solutions already been developed by companies without even understanding the problem. So it's like, I have a solution, let me go and find out the problem. I think this is the problem of the industry of wireless power. That is why it has not succeeded. Rather than looking into a problem, seeing the scenario, like very good example of what John has faced and you guys have done, that's why it's become a success. That's why you guys are all sitting together now, because you identify a problem and then you say, yes, there is a technology which can help you to solve that problem. Rather than saying that, oh, I have this wireless power solutions, come and let me use that. Let me cut your cords. It's as simple as that. I'm saying that going further, the adoption level of wireless power will increase a lot. It will spread across many more applications rather than mobile phones and laptops and tablets or electric vehicles. It'll go everywhere now, because companies hopefully are becoming more sensible or more disciplined with regards to promoting a technology for the right solution out there. More of that sort. Rather than saying, oh yes, I have something magical in my hand, let me go this. And many companies or many OEMs or many enterprises are thinking wireless power is nothing, but it's more about replacing your connectors, power connectors, with your coils. It's wireless power is not about changing coils or adding coils or antennas in your devices. It's much, much more than that. And very interesting, in fact, for the last 6 months, I'm seeing many solutions being developed for wireless power, not for charging. Wireless power is just a medium through which you're achieving many more features for a particular device. One example I would give is for data. If there was no wireless power, there were many applications in the industrial environment, in the enterprise environment, where it wouldn't have got active, like sensors and all. It's very important now for companies to get data from those sensors. And that data is not a static data. It's not like once in a year data or once in 6 months data. They want live data, real life data. So I think that can only come with wireless power. It could possibly come in powered, but no, it's not feasible. It's not practical. So I think that's where I think the success of wireless power will come, and it will speed up at much, much faster rate now. The success rates hopefully will be much, much faster now than we had seen in the past, because there has been a reality check done now, and we now know where we stand and what could be promoted. That's what I would say.
Thank you, Dinesh. Robert, let's go to you. Same question.
Yeah. So, yeah, thanks. So I think one of the things that I would consider a success in the next few years would be to see wireless power being deployed in infrastructure. So this is something that Jeff and I talked about for years when we first were forming our company, which is that wireless power inherently has both a transmitter and receiver. And the approach that we decided to explore was this approach I mentioned earlier, is to maximize flexibility. And so we create this magnetic field within what we call the power zone, and it enables all devices within that zone to move about freely and get power. But that requires a transmitter that has a loop of wire that encircles that zone, and it defines certain boundaries around that zone. So once you leave the boundary, the field drops off very rapidly, and then the device loses power. So for the devices to exist within the zone and receive power, they need that infrastructure. So they need that transmitter. And we talked about this historical examples of technologies like that need some infrastructure. So there's things like all the electrical appliances that were developed throughout the 20th century. They needed the electrical distribution system, which was developed in the late 1800s. And so when people had electric washing machines installed in their homes, those were not useful unless there was a system to distribute power to that home. And so it was a chicken and egg problem. So how do you get people to agree to have wires run to their home if they don't have any devices to power with them? And how do you sell them devices if they don't have the wires? And a lot of that initially was that infrastructure was motivated by just the light bulb. So that was the first electrical device that really had widespread adoption. And it was a sufficient value that people were willing to pay for that infrastructure just for that one device alone. And so in the early 1900s, you had people retrofitting their homes with wires just for light bulbs. But once those wires were there, that opened up possibilities for all sorts of other devices. So electric fans, electric washing machines, electric refrigerators. And a lot of those very early devices, if you look at some of the old antiques, that the electrical socket, it's not the two-pronged socket or three-pronged socket that we use today. It was actually a light bulb socket. It was designed to screw into a light bulb. So when you're running your washing machine, you'd unscrew the light bulb from the room and screw that in there because that was the infrastructure that you had available. So I think in our case, we know that that's the same problem that that our technology faces in terms of adoption. And more recently, Jeff and I were watching an interview with Jensen Huang. He was talking about the same thing when NVIDIA was first developing GPUs. It was a new way of doing computation, which was completely different from the CPU architecture. And it enabled all sorts of new possibilities that weren't available before, but nobody wrote any software for them because that hardware didn't exist before their company created it. So how can they get people to adopt this hardware when there was no software for it? And how could they get people to write the software until the hardware has been deployed into the marketplace? And so the first way that they got into that market was by deploying this for computer games. They basically created a new market to take the arcade games and put them onto a computer. And so I think what we're finding with our companies, we're finding those high value applications in the marketplace where there's enough value of the solution to motivate the introduction of this new infrastructure. But once that infrastructure is there, it's easy to create new wireless power products that utilize this existing infrastructure. So just as soon as you have GPUs widely deployed for video games, people can discover they can use them for cryptocurrency mining or training AI neural networks and things like that. So once you have this infrastructure in place, people will discover new ways to use it and will create new value for it. So it'll make the infrastructure itself more valuable and open up new value for these new applications that were never possible before. So I think that's what we would look for success, which is finding these high value markets that will adopt our technology and deploy it, and then enabling the opening up of new possibilities that never existed before once this infrastructure is available to people who have creative ideas.
Jeff, over to you. You get the last word on this. Looking out ahead 3 to 5 years, what does success look like in the wireless power world?
Yeah, I think I will second exactly what Robert has been saying. I think we developed this as an infrastructure. So what I would like to see in the next 3 to 5 years is there are more and more companies that adopting our approach and actually deploy this install base system into their own environment, and created a whole new, I would say creative products or a solution for human to interact with that, easily. I think so wireless power, I would say this is more of a electrification. So this is back to what Robert was saying, electrification actually developed for over the century now, but the way that electrification infrastructure is being deployed is actually has no different than what it is 100 years ago. What we created is actually a new way of a deploy infrastructure. We deploy infrastructure in the modular form, so you can actually prefab that in the factory instead of having wiring on site. We actually trying to make this massively easy for installer to install electrification into their environment, so they can spend more time to develop a new product or new class of a product. That what Robert was saying, that is an enabler. And we spend all these years in, sort of in the lab. We develop every aspect of the engineering, having that in the mind. So the companies that we work with, they can actually simply adapt what we have built on the transmitter, which is become an infrastructure. Then hopefully they can spend less time or no time at all that deploy to their environment. So they can spend more time to think about what products they want to bring to the market, how that interact with a human. That is actually going to be completely different shift. So for the next 3 to 5 years, what it looks like a successful outcome, will be multiple industries with the multiple different types of applications that simultaneously adopting this and deploy massively until the stage, I would say, probably it's going to be 5 years until two different, completely different industry that actually will cross-talk to each other because the fundamental infrastructure become overlapping to be the same. So all of a sudden, you have a new type of industry can be formed. Like I don't know, like you have a lighting industry, then you form in with a display industry, which is also doing lighting. But there may be a different way of interacting with the light and the display. Maybe there's a different way interacting with something that is moving with a light. So we are hoping to see the industry sort of intertwined together into a holistically fabric to create a whole new class of products that just never existed before. So yeah, so that actually require a lot of work. So, no single company can do that. This is where, our system as a platform, we actually welcome, every company to talk with us to think about how we can collaborate. So that's how I see the next 3 to 5 years, Tom.
Thank you, Jeff. Appreciate that. We're coming up on our time, so I'll close with this. What you've heard today is that wireless power is no longer a question of if, it's a question of where and how. The technology is proven, the physics are understood, thanks to Robert Jeff, and the regulatory paths are established. What matters now is execution, designing systems with clear boundaries, building compliance in from day one, and deploying wireless power where it can improve reliability, serviceability, and lifecycle performance. Wireless power isn't a feature, it's infrastructure. And when you remove physical power interfaces, you remove entire classes of failure, maintenance, and operational friction. That changes how products are designed and how they scale in the real world. So here's my invitation to you. If you're an OEM or an ODM evaluating next generation products and wireless power is something you're actively considering, we're ready to engage. That means evaluation, architecture discussions, design and support, compliance planning, and pilot programs that move quickly from concept to deployment. I want to thank our panelists for sharing real-world experiences and practical insight, and thank you all for joining us today. We'll be following up with materials, including the DIY Perks video, and ways to contact us, and we look forward to continuing the conversation. Wireless power is ready, and ETI is ready to deliver. Thanks again, and have a great rest of your day.
Thank you very much.
Bye all.
Thank you.
Thank you. Thank you very much.